Hi, let's study. In bridge engineering inspection technology, reinforcement distribution in concrete, and detection of cover thickness. This knowledge point. This test targets main load-bearing members, or primary stress-bearing locations of load-bearing members, generally under the following two conditions need to be tested. First, estimate the rebar in concrete position, depth, and dimensions. Second, in the absence of data or other reasons, when structural investigation is needed. First, test method. An electromagnetic non-destructive testing method is used in engineering. Determine rebar position, supplemented with on-site correction to determine cover thickness. Estimate rebar diameter. Second, testing steps. Step 1. Instrument calibration. Rebar cover thickness tester. Calibration during use. Special calibration blocks should be used. When measuring calibration blocks, when the given cover thickness, the reading should fall within the accuracy range specified in the instrument manual. Step 2. Before testing, understand structural drawings and documents to determine the type and diameter of rebar. Step 3. Before measuring the cover thickness, first determine the measuring area and the position or direction of rebars within it. Measurement area determination must satisfy the following three conditions. First, when testing individual components, should be based on size. Evenly arrange measurement areas on components. Measurement area on each component should not be fewer than 3. Second, for components with maximum size greater than 5 meters, the number of measurement areas should be appropriately increased. Third, measurement areas should be evenly distributed. The spacing between adjacent measurement areas should not be less than 2 meters. Rebar position and orientation. Determine according to the following steps. First, place the cover thickness tester sensor. Move parallel on the component surface. When the instrument displays the minimum value directly below the sensor, that is the position of the measured rebar. Second, after locating the rebar position, keep the sensor in place. Rotate left and right by a certain angle. When the instrument displays the minimum value, direction of the sensor's major axis indicates the direction of the rebar. Step 4. Measurement of cover thickness. First, place the sensor at directly above the rebar position and slightly move left and right. Read the minimum value displayed by the instrument, which is the cover thickness at that location. Each measuring point should be read. 2 to 3 stable readings. Take the average value, accurate to 1 millimeter. Step 5. Correction of protective layer measurement values. When rebar diameter, material, rebar arrangement condition, and concrete properties are unknown, measurement values need correction. Calibration holes are commonly used in engineering. To conduct comprehensive correction, obtain correction value. The operation steps are as follows. Use a 6 mm drill bit directly above the rebar position. Drill holes perpendicular to the component surface. Stop immediately when the sensor touches rebar. Measure drilling depth with a depth caliper, which is the actual cover thickness, S. Then the correction coefficient K is calculated according to equation 4:1. Step 6. Data processing. First, should follow each measuring point at the measurement location. Measured value of concrete thickness. Calculate the average thickness of concrete protective layer D. Second, calculate measurement locations using equation 4:2. Characteristic value of concrete cover thickness DNE. Step 7. Rebar cover thickness assessment. Based on actual measurements at the measurement location. Characteristic value of cover thickness DNE. Ratio to its design value DND. Refer to Table 3:1 for evaluation. In the end, I will summarize the content of this lesson. In this lesson, we mainly studied reinforcement distribution in concrete and the cover thickness, test methods and steps, data processing and evaluation methods for cover thickness detection of steel reinforcement. As future bridge engineers, we must follow professional standards with a high sense of responsibility and the spirit of continuous improvement to complete bridge construction, ensure bridge safety,